In this video, I'm going to be working you through polynomial and rational inequalities. While this is marked as extra material, this is required for Math 161. This will be present on your final exam. So by the end of this lesson, you should be able to solve and analyze basic inequalities. This is going to be review. It should take us no time at all. Then we're going to solve inequalities for polynomials. There's a little bit of some tricky tricks that we can use for that we can't necessarily use for basic inequalities. And then we're going to use the solutions of polynomial inequalities to first state the domain of complicated square root functions. And then we're going to analyze the sign. And when we say sign, what we mean is like positive or negative of a rational function. And remember that a rational function is a polynomial divided by a polynomial. So first, we're going to do just a basic demonstration. We're going to solve the given inequality. Enter your interval using exact interval notation and exact values. So go ahead and take a second, pause the video, and work this one out. Okay, so in order to solve this, the first thing we want to do is decide where we want to move our variables. So I'm going to go ahead and move the variables over to the left-hand side. I'm going to subtract 5w from both sides. So now I end up with negative 3w minus 3 is less than or equal to negative 7. Now I'm going to add 3 to both sides. And now I have negative 3w is less than or equal to negative 4. Now, what I'm going to do here is I'm going to divide both sides by negative 3. Now, as a result of dividing both sides by a negative, remember, you're going to change the direction of the inequality. Then I end up with w is greater than or equal to 4/3. Now, from here, with an inequality, you don't just have one solution. You've got a collection of solutions. You have an interval. So if I were going to do a number line, just as a frame of reference, well, since it's greater than or equal to 4/3, I'm going to include 4/3 in the solution, and I'm saying w is greater than, so I'm going to go to the right. And now I'm going to state this as an interval. So 4/3 is going to be included, and I'm going all the way to the right, in particular positive infinity. So that's going to be my solution. As a note, the one thing you need to remember here is when I multiply or divide by a negative, what you're going to want to do is switch inequality direction. Okay. Now, really in summary, what I want you to kind of walk away from this slide with is, solving a linear equation is basically the same as solving, well, what we'll say actually, since it's basically the same, is it's approximately the same thing as solving a linear inequality. The one thing we have to mind, we'll call this rule star. We just have to mind this star rule, okay? That's the only thing we need to remember, okay? Now, let's review roots and multiplicities. This is going to seem a little out in left field, but it's going to come into play as a legitimate method for solving polynomial inequalities. If I were to have a factored polynomial, in order to find the roots of that polynomial, I would set each factor equal to 0. And then I would solve for my x value. Now, as a note, multiplicity is the power of the particular factor. So if a particular root has a multiplicity of 1, it could either crash through the x-axis like this or like this. but ultimately it's going to crash through. If a root has multiplicity of 2 or 4 or 6, etc., ultimately even, it can bounce off the x-axis like this or like this. If a root has a multiplicity of 3 or 5 or 7, all odd numbers that aren't 1, it can kind of swoop through the x-axis like this or like this. This is really helpful for graph sketching. Now, as a review, and if you need to kind of look back for this, this is a little 3.1 review. Remember the chart for end behavior. If I've got an even degree and a positive leading coefficient, then the arrows on the graph are both going to point up. Whatever's happening in the middle doesn't matter. If I've got an even degree and a negative leading coefficient, both arrows are going to point down. And if I've got an odd degree and the coefficient's positive, then one arrow is going to go down, particularly the one to the left, and then the one to the right is going to go up. And for negative, the arrow to the left is going up and the arrow to the right is going down. Okay, so keep that in mind. It's going to really help here. Just as a note, for this polynomial in particular, that leading coefficient is going to end up being 1. Now, let's use just basic information to make a sketch here. Let's start with the roots. Always start with the roots. Since I have a factor of x minus 2, I would set x minus 2 equal to 0 and solve for x. I get x is equal to 2. So if I were going to sketch a graph of this thing, and again, this is a sketch. At 2, I've got a multiplicity of 1. I'm going to crash through the x-axis. Okay. Do the same thing here. I'd have x minus 4 is equal to 0. So at x equals 4, observe I've got a multiplicity of 2. So what's going to happen at 4 is I'm going to bounce. Now from here, again, just as a review, there's one of two graphs that I can have. I could either come from down here, crash through, and then bounce off 4, or I could come from the top, crash through here, and bounce off here. We see that these graphs exhibit the same properties at the roots, but they're fundamentally different graphs. So what I need to pay attention to now is the leading coefficient. So my leading coefficient is 1. And observe here, if I've got a root of multiplicity 1 and a root of multiplicity 2, my degree is 3. So since the leading coefficient is positive and the degree is odd, what I'm looking at is the green graph. Okay, so this is my sketch. Now, this sketch is going to be vitally important on the next slide. So, for this particular polynomial, we're going to go ahead and solve this using test values. I'm going to kind of talk about how that sketch could be really helpful to us later, particularly as we move into a different example. But I want you to refer to the slides that have been released to the class for this so that you can kind of see what's going on there. But I don't even mind going through it real quick. So what we're saying here is this polynomial is less than 0. So if I wanted to solve this inequality, and let's suppose that I actually had this thing here, x minus 2 is less than 0. From this sketch, what I'm really asking for, since it's less than 0, what I'm really saying here is below x-axis. So where on my graph am I below the x-axis? Well, here. Now at 2, notice that I'm on the x-axis, that's not below. So my solution from using this graph sketch, so everybody to the left, okay, so that's going to be negative infinity, all the way up to 2, but not including 2. So this is one method of solving the inequality, is you can make a graph sketch and then just interpret, okay, well, am I above the x-axis or below the x-axis? Do I include points on the x-axis? We'll see some more examples of this. Now here, I'm going to show you a completely different method where we're going to use a sign chart. This actually is really agreeable, and I think that this is actually a much better way to solve these inequalities, particularly as we get more complicated problems for the third objective when we're talking about with particular applications. I think you'll find the sign chart to be really, really helpful. So I'm going to go ahead and put a little star by this so that you guys know that this is super duper important. So first thing we're going to want to do is compute the roots. Well, from the last slide, we already did this. So I don't mind leaving you to your own devices on this. And if you notice, I don't need to say anything about the multiplicity. So that's kind of nice. Now here's what I'm going to do. I'm going to make a number line, and I'm going to make kind of like a master number line up here. And I've got 2, and I've got 4. There's a 0 here and a 0 here. Now I'm going to check test values. So the way test values work is I check representatives from each space that's enclosed by the roots. So I'm going to check to the left of 2. I'm going to choose 0. In between 2 and 4, I'm going to choose 3. And beyond 4, I'm going to choose 5. These are going to be my test values. And what I'm looking for here is what is the sign, positive or negative, of the polynomial at these particular test values. So let's check x equals 0 first. So I'm going to do purple for this one. So go to the original polynomial and plug 0 in everywhere you see an x. Mind order of operations. 0 minus 2 is negative 2. 0 minus 4 is negative 4. Remember that I'm squaring this. So I end up with negative 2. Oof. Okay. Negative 2 times 16. That's negative 32. Now, the fact that it's negative, or the fact that it's negative 32, that's not really that important. The thing that is the negative. So what I know is all of the values of this polynomial are negative when I go to the left of 2. Now let's see what happens in between 2 and 4. So for this one, I'm going to use a dark blue. So I do the same thing I did before with 0. I plug 3 in. And I end up with 1 times 3 minus 4, that's negative 1 squared. I'm going to square that, so I get 1 times 1, that's 1. Note here that this is a positive 1, so what I know is the polynomial is above the x-axis in between 2 and 4. And now I'm going to check what happened there. Why did this happen? What happened? Oh, there we go. Sorry about that. Now we're going to check at 5. My heart jumped in my throat. I thought I had to do another take. Whew. Sorry about that. Okay, I think that we're good now. Sorry about that. I thought I had to do another take. My heart jumped into my throat. So now we're going to plug 5 in. And so now we end up with 3. 5 minus 4 is 1 squared. So that's 3 times 1, that's 3. The 3 is not important. What I know now is this polynomial is increasing. Or it's, I'm sorry, it's not increasing. It is positive to the right of 4. So now keep in mind, what I really want here are these roots where I'm negative. So where am I negative? I'm negative in this space here. So that's so we also did step 3 here where we documented the sign. And now we select the appropriate intervals. Well, that's going to be from negative infinity to 2. Now, I understand that like you're going to be fixated on 0 here. 0 is just a test value. There's absolutely nothing special about 0. We could have chosen -1, we could have chosen -5, we could have chosen 1. Didn't matter. Anything to the left of 2 is what we wanted to pay attention to. So this is using a sign chart. This is really just plugging numbers in and seeing what comes out. We need the roots as a frame of reference so that we know which numbers we should be plugging in. And root finding at this point, you guys are very, very good at from chapter 3. Now, let's suppose I asked you to solve this inequality. We're going to use a graph sketch for this first. So as with all things, what we want to do with our graph sketch is we're going to start with identifying our roots. So in identifying our roots, what I'm going to start with is factoring, always and forever. Let's see if we can factor this really nicely. So I factor out 3x, and then I'm left with x squared plus 5x plus 2. Okay, well, here I see that I'm going to set 3x equal to 0, divide both sides by 3, I get x equals 0. That's a root. Wonderful. So if I'm going to have my graph sketch down here, I know that there's going to be a 0 at the point of origin. Now this thing here, I'm going to have to use the quadratic formula for this. That's an A. What I want you to do is pause the video for me and use the quadratic formula here. Okay, if you use it correctly, what you should have gotten was -5 plus or minus the square root of 17 over 2, which means we're going to have two roots, one at -5 minus the square root of 17 over 2, and then -5 plus the square root of 17 over 2. This first root here is going to be approximately, let's see, that's going to be a little bit over 4. This will be about 9, -4 point blah, 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 blah. And then this one here, approximately, is going to be -0.4 blah, 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 blah. Okay, so that's fine. I see that each of these roots are going to have a multiplicity of 1. I've got my 0.4, blah, 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 blah. And then my -4 point blah, 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 blah. All right, so here are all of my roots. And now just as a note, keep in mind that these are the exact values. We may end up needing to refer to those when we actually write our solution. All right, now let's talk about our end behavior. So with our end behavior, we need to consider the degree and the leading coefficient. The degree here is definitely 3. And the leading coefficient, well, that's also 3, but more importantly, it's positive. So what that means is, in terms of our rough sketch, it's going to look something like this. Oh, goodness. Well, whatever. It's a sketch, right? Okay. Now, here's what I want to know. I'm going to choose my correct, I'm going to choose the correct information based on my inequality here. What I'm saying is this is greater than 0, which means it's positive, which I can also think of that as above the x-axis. Okay. So here's all of the spaces that are above the x-axis. And now, as we identified before, let's go ahead and start with this space here. This is just going to go from 0 to infinity. That's great. And now this space in the middle here, remember this is this negative point or 4 point, that's this term here. So we're going to start there. And I'm going to end at the plus here. All right. Being left-handed and writing in the pen feature for PowerPoint is a nightmare. All right, so. And then I've got two spaces, so I'm going to use a union. That's my solution. Okay, now this was using a graph sketch. If you have a particularly strong memory of 3.1 and 3.3, I think that this is going to take you no time at all. And personally, I really like doing the sketches. I think I think it's quick and it gives you a really global understanding of what the polynomial is actually doing. But if you find this unsavory, you could also use your sign chart. So as from the last slide, computing the roots, we're not going to make a big giant thing about that. We already know from the previous slide that our roots were x equals 0, x equals -5 minus the square root of 17 over 2, which was that -4 point blah, 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 and then -5 plus the square root of 17 over 2. And that's our -0.4 blah, 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 blah. Okay, now we're going to check our test values. So I'm going to do one master interval here so that you see everything. All right, so at 0, I've got a 0, and then negative square root of 5 plus the square root. Whoa, where's the square root coming from? Good question. I was testing you. I wasn't. I made a mistake. And then -5 minus the square root of 17 over 2. Again, you could just think of this as -4 point blah, blah, blah. And then this is -0.4 blah, blah, blah. All right, so now what we're going to do is choose test values. So we've got 4 test values that we need to check here. And my advice to you is choose the nicest possible test values. So let's do -5. And then in between -4 and -0.4, let's say -1. And then in between -0.4 and 0, let's say -0.1. And then beyond 0, let's just go ahead and choose 1. So just so that we don't lose the thread here. And again, I don't care what the numbers are. The numbers are, the y values are really not important. It's really just a question of, you know, what's the sign? Is it positive or is it negative? That's all that we care about. All right. So let's start with -5. And let's see what's going on here. So I'm going to plug -5 in. And what I like to do is keep this thing in its factored form, which we saw from the last slide. Let me go ahead and write that up separately. From the previous slide, we had 3x x squared plus 5x plus 2. So let's plug -5 in. And we'll do that in maroon. And you're going to see that I'm going to get kind of quick here. But that's all right. So here's what I know. This number here is going to end up being a negative. Now, -5 squared, that's 25, plus 5 times -5, that's -25. So that's going to be a 0, plus 2. That now changes into a positive. And these are being multiplied. So a negative times a positive is a negative. So that's going to be negative up to there. And then I forgot to put my zeros on there, just as a frame of reference. Okay, so that takes care of that test value. Now let's check. Now let's check -1. Goodness. -1. -1. All right, so I'm going to use green for that. So let's plug -1 in. So I get 3 times -1. I get -1 squared. Again, you're going to see me be kind of quick about this because of practicing with these types of numbers. So 3 times -1, that's going to be a negative. And then negative 1 squared, well, that's 1, plus 5 times negative 1, that's negative 5. So then negative 1 minus 5, that's negative 4, plus 2. That's going to be a negative. And this is a negative times a negative, so this is going to be a positive. All right, cool. So, all right. Now, negative 0.1, you may need to sort of plug this in, but again, just a little bit of sign analysis, and you may be able to dodge that. So let's do this in orange. So 3 times negative 0.1. Well, we know that's going to be negative. And then negative 0.1 squared plus 5 times negative 0.1 plus 2. Well, this is going to end up being negative, but then plus 2. That's going to make it a positive. A negative times a positive is a negative. All right, so. And now let's go and try 1. Don't be silly. Choose the right thing. And so now I've got 1. I'll do this in light blue. 3 times 1, 1 squared, plus 5 times 1 plus 2. This is definitely going to be positive. And then all of these numbers are positive, and I'm adding them together, so I know this is going to be positive. Positive times a positive is a positive. All right, now I'm going to use the same type of thing. I'm going to use the same type of thinking. I'm going to choose the appropriate intervals, which I see that those are going to be here and here. So my intervals, I'm going to start at negative 5 minus the square root of 17 over 2. And I'm going to go up to negative 5 plus the square root of 17 over 2. Remember the exact values for this. And then from 0 to infinity. And that was the same solution I got from the last method, which makes sense. So this is going to be our solution. Okay. And we used a sign chart. So 2 totally different methods that gave us the same result. Now, applications of solving a polynomial inequality. So when do we ever actually need to be able to do this, aside from just like when it's asked on our math homework? So if I've got a square root function, right? So here's my square root. If this polynomial that's under the radical is negative, then we've got something that's not a real number. So we can only allow positive x values, right? We can only allow positive x values. Now, as a note, we can also allow 0. 0 technically isn't positive or negative. So 0 and above, we're allowed to put under this radical, and it fits in the domain of p of x. So what we really want is a solution to this inequality. That's when we're going to find the domain. Okay, so we need to solve this, and I'm going to use test values to do this. So we're going to start by computing the roots. And what I'm going to do here is I'm just going to rewrite this to be negative x squared minus 10x minus 24. I'm going to factor out a negative, and I end up with x squared plus 10x plus 24. I'll give you a second to factor that. All right. You should have x plus 6, x plus 4. This negative 1 isn't going to contribute to a root. So I've got roots at negative 6 after I set this equal to 0, and negative 4 after I set this equal to 0. All right. So now I'm going to check my test values. So what I'm going to do here is do my master interval, or my master number line. Negative 6, negative 4. That's a 4. And now my test values, again, the assignment of these, no magic. We'll say negative 7, we'll say -5, and we'll say 0. For whatever reason, I love plugging 0 in. So let's start with -7. Goodness gracious. I promise I can write. I promise. Okay. So again, I only care about the sign. All right, so this is a negative. -7 plus 6, that's going to be a negative. Then -7 plus 4, that's also going to be a negative. Negative times a negative times a negative is a negative. So I know that all of those values are going to be negative. Now, I'm going to use orange, and we're going to check -5. All right, so -5 plus 6, -5 plus 4. All right, so I've got the -1 that was waiting out there, -5 plus 6, that's going to be a positive. And then I've got -5 plus 4, that's going to be a negative. Negative times a positive times a negative, that's a positive. Okay. And now I'm going to go ahead and check my last one, which I'll do in purple. Let's check 0. All right, so I've got a negative 0 plus 6, 0 plus 4. So I've got a negative, and then 0 plus 6, that's a positive. 0 plus 4, that's a positive. So I've got a negative here, so I'm negative. Now, here's something to note. For choosing the appropriate interval, there's no question about this. It's going to be this space here. Now, since I can equal 0, right? Since I can equal 0, I need to include these particular points. Okay? So for step 3, I'm going to choose my appropriate interval. I'm going to include the zeros because I'm allowed to have those. -6 to -4. Okay? So what we know is that if I'm going to plug an x value into this function, into this square root function, if the x value is anywhere between -6 and -4, then we're going to get a nice number. Well, nice with the tentative definition. We're not going to have a complex number is really the main thing here. Now, suppose I wanted to solve a rational inequality. Ultimately, what I've got is a polynomial over a polynomial because it's a rational function. And there's one of 4 things that can happen there. I'm sorry, my son really wants to come in and help me deliver this lesson. He's very helpful. There's one of 4 things that can happen. So case 1, that's going to be where I've got a positive over a positive. That's going to obviously give me a positive number, which means the rational function is positive. Case 2, suppose I've got a positive number over a negative. Well, that's going to end up being a negative number. Case 3, I could have a negative over a negative. That's a positive number. In case 4, that's a negative over a positive. That's a negative number. Okay? So let's suppose I asked you to solve this rational inequality. Well, what I'm really asking you to do here is use 2 sign charts in tandem with one another. I want to know when it's greater than or equal to 0. So what that means is that this is going to end up being positive. So since this is going to be positive, what I really want is case 1 and case 3. Okay, just for my own edification, I'm going to put down the intervals where that happens. So let's do our sign charts. First, we're going to look at the polynomial in the numerator. And here it's pretty clear that our root, since it's just x minus 4 in the numerator, is going to be x equals 4. For the polynomial in the denominator, we're going to have a root at x equals -2. So now what I'm going to do is set up my sign charts. Okay, we'll call this function A, and we'll call this function B. So let's set up sign chart A. And then I'm going to set up sign chart B as well. And I want them to sort of interact with one another. So I'm going to go ahead and label particular points. For B, I'm going to want -2 on there. And for A, I'm going to want 4. It's really helpful to have these side by side for real. So what I'm going to do is put my zeros there. Boom, that's a 0. That's a 0. Now, obviously, the zeros at these particular things mean different things necessarily, but we're not really interested in that entirely, okay? Just yet. This is just so that I can keep note of my spaces. So I'll go ahead and label this -2, and I'll label this 4. Now, here's what I'm going to do. I'm going to go ahead and do test values for A first. So let's do test values for A. I'm going to choose, I don't know, from -2 to 4. I'll choose 0 and 5. All right, so let's do x equals 0. And again, I'm only paying attention to the function x minus 4. And x equals 5. All right, so I get 0 minus 4. That's a negative. All right, cool. So negative. And then 5 minus 4, well, that's a positive. Okay, cool. Now I'm going to take a look at my function b. And again, keep in mind, this is just the function x plus 2. So now let's choose something to the left of this. We'll say -3. And then let's say to the right of this, we'll choose 0. That's kind of nice. Again, now notice I don't need to use the 4 because that's already to the right. So who cares? So let's do x equals 0. And so I get -3 plus 2. That's negative. All right, so then this is negative. And then 0 plus 2, that's positive. Okay, so now I'm positive. Now I'm only interested in case 1 and case 3. Case 1 is when I had a positive over a positive. Well, where is that happening? Well, case 1, positive over a positive, that's happening here. All right, so that's going to be 4 to infinity. All right, infinity I'm definitely not going to include. Now, notice here, I'm saying it's greater than or equal. So when x minus 4 equals 0, this thing equals 0. Remember when I have a 0 in the denominator, I get an asymptote, which is a totally different beast. That's not something I'm going to pay mind to. But this x minus 4, when x equals 4, this whole function comes out to be 0. So I'm going to bracket that. Okay. Now, let's look for case 3, where I've got a negative over a negative. Well, that's going to be here. Well, what space is that? Well, it's going all the way to the left, so that's going to be negative infinity. And it's going to stop at -2. Now, again, just because there's a 0 here, remember that 0 is going to be in the denominator, which that is going to be an asymptote, so we can't include -2. So there you go. We're going to union our spaces. I know that it's not necessarily the way that we're used to writing them, where it's like leftmost space to rightmost space. Doesn't matter. So this is my solution now. I really love sign charts just for this reason. Okay, now let's work this one out. Here's what I'm going to do. I'm going to leave the particulars to you all to read through the slide if you need. But what I'm going to do is give you the first step to kind of help you along the way. This problem is clearly different from this problem because here we have 2 things and here we have 1 thing. So what we need to do is get these 2 things, okay, down to 1 thing, and then we can go from there. So what I'm going to do here, I'm going to observe that these denominators are not common. So I'm going to need to do a little bit of fraction analysis. So in order to get the denominators the same, I'm going to give this guy here a p over p. I'm going to give this guy over here a p minus 2 over p minus 2. Okay, I'm going to distribute the 3. Well, this is a negative 3, right? And so then I end up with 4p over p times p minus 2. And then we'll say, well, let's just go ahead and distribute it. So now I'm going to say plus negative 3p plus 6. Really be intentional about distribution of the negative. Students that tends to be the mistake. Since these denominators are now the same, I can put the numerators together. And so 4p minus 3p, that's just going to be p plus 6 over p minus 2. Now, I'm going to leave you to look at the particulars with the sign chart. What I want you to observe is that for this guy here, you're going to have 2 zeros. So make sure that you keep that in mind. Your final solution, and if you want to kind of pause the video and work this out on your own, go ahead and do that. If you need to refer to the slide to see exactly what happens next, it's almost exactly the same problem as the one prior. Go ahead and do that. Now your final solution should be negative infinity to negative 6. You should have a bracket around the negative 6. Okay. Union 0 to 2. You should have parentheses around this. Okay. I hope this has been helpful. Good luck out there.